Okay, started the live stream. I think it's working. Make sure I've got internet. Looks like we've got internet. Okay. I guess let's start off with a word of the day. Cheese. Okay. Good memory. Cheese.
My MAT091 still won't let me log in.
So you're not able to log in.
I'm on the page and my login credentials, and then I press log in. Oh, well, now there's no internet, but it just stays on that page.
But
you click it and then it like loads and then it just stays.
And doesn't give you an error message or anything. Okay. Well, let's. I've got to pull it up here, so let's. Let me see if I can get it to recreate that situation. Where's my keyboard? Put in it's yeah, so if I put in the wrong password, it just it flashes back. So there's something so what I would suggest doing is go with forgot password. And if you're not able to get in that way, I can reset it to a standard, and then when you log in the first time. So, but I think it's a password issue, and sometimes it should give you a message, but it doesn't. It just comes back, and yeah, it looks like that's all it did. It came back. Right? Shouldn't it say wrong password or something? Or, see now what do I think I just took one out. Nope. See now it's not going to let me in. Sorry, we're gonna have to cancel class now because I can't get into MAT091. No, I can. Okay, so we're okay. What class? We're 91, aren't we?
91.
Okay, 91. And there. Oops, let's make it a bit smaller. So, when's our next test?
Never. Never.
Till after spring break, so who cares, right? It's long enough, almost like never. Infinite amount of time away. So after spring break, so we're okay. We've got, today is Wednesday, and then we got next week, Monday and Wednesday, and then we've got spring break, so a week off. So my goal is to get us, and notice the next exam's here. We'll look at formulas and patterns and introduction to functions. I think what we're going to start to see is things become a little bit more concentrated as we go forward. So remembering Unit 5 was graphs. Again, most of that stuff we don't test you directly on it. It's stuff that we will use in these other three units. And supposedly we can sort of forget about these because we're not going to test you on them again, although you'll see they are kind of related to what we're going to do. You had a question for something from Unit 5?
Lesson 5, number 13.
Question 13. Okay, so I'll take a picture of this screen so we got the word of the day. And let's go into the desktop. What's going on? Oh, there it is. Why is it over there? Okay, so I'll get this out of the way. So we've got this graph. It shows Sally's distance from home over a 42-minute time period. Use the graph to answer the questions. So down here we have time in minutes, and over here we have the distance from home. So the y coordinate gives us distance from home. The x will give us the time. So interpret the meaning of the vertical intercept in this situation. So where's the vertical intercept? It's the distance. It's here. And so it's about 21. And how many minutes has Sally been traveling?
0.
0. That's what the vertical intercept is. After 0 minutes, Sally is 21 miles from home. Okay, that's basically this point right here. Oops. I want to turn that part off.
That's what I do sometimes. I flip it around in my mind.
Yeah.
We're talking about.
This is the point 0, 21. And that gives us 0 minutes, 21 miles from home. The horizontal intercept, that's over here. And so that's after 42 minutes. And what's the y coordinate at this point?
0.
0. We're not up or down. So, and what does that mean?
And then the x.
Well, it means that after x is 42 minutes, how far is Sally from home?
She's at home.
She's at home, 0 miles. Okay, and you'll see, I think this is the lesson where we do a lot of vertical and horizontal intercepts. It always has 0 involved in one of them, but vertical intercept has 0 for x, horizontal intercept has 0 for y. If you can keep those two straight, everything will be good. And then interpret the meaning of the ordered pair 2, 20. Again, x is minutes, and y gives us how many miles. Okay. So that's how that one works. So reading things off of a graph, and what we're going to do is, well, we'll see in 6, I think we're going to be talking a lot about horizontal and vertical intercepts. So we'll be working with these values, but we're not always going to be given necessarily a graph. Sometimes we're working directly from an equation.
So in 6 we'll be working with horizontal and vertical intercepts.
I believe so, if I remember correctly, but okay. Why don't we just take a look? That's the best way to just dive in. And take a look at the workbook. So a couple of things we're going to take a look at is whether or not we should connect the dots on a graph. So again, kind of tying in with what we've done with graphs. We'll be looking at equations in graphs, so not just the graphs, but how the equations relate to a graph, and then graphing equations by plotting points, and then intercepts, yes, here in 6.4, and horizontal and vertical lines. So as far as today, if we get through 3 of these, that'd be good. We might take a little look at the intercepts. Again, this ties back to what we did a little bit in lesson 5, so we'll see how far we get. And then what we'll do is on Monday, we'll pick up wherever we left off. And if by the time we get to spring break, if we get a little bit into 7, which finish up 6 on Monday, get into 7 on Wednesday, we'll be in good shape. In fact, I think we'll actually even be ahead. Okay, so.
On next Wednesday, week from today, spring break starts on the 12th?
Something like that. Well, it starts the week after next. So, yeah, we're here at least through Friday of next week, this Friday and the next Friday, and then the week after that is spring break.
Oh, I thought. So after next week, the following week it's.
Yes.
Okay.
Yes. Okay. So, and this is, again, not necessarily something you're going to get tested on, so don't look at it that way, but just in general, comes up this question, when should we connect the dots and when should we not connect the dots? Okay, so let's see. Go to the store and you're buying packaged cereal. This comes in a box. Can you buy half of a box of cereal? No. Go to the store and they're selling it in bulk. Can you buy half a scoop of bulk cereal? Sure, you could buy one little Cheerio if you want. You put that in the bag. And so if you're buying bulk cereal, you can buy any quantity you want. So that might be, there might be a certain amount, per pound that they're charging, but you could put into the bag, the bulk bag, really just anything you want. So that's when it would make sense if this graph is about buying cereal. The line would make sense if it's in bulk, because you could buy any amount that you want. Okay. But if we have to buy it by the box, you can either buy 1 box or 2 boxes or 3 boxes or 4 boxes. And this might be cost, say it's $1 per box. Buy 1 box, you pay $1. You buy 2 boxes, you pay $2. 3 boxes, you pay $3. But in the bulk bracket, you don't have to buy a full pound. You could. 1 pound costs $1. But you could buy half a pound. You could buy a quarter of a pound, and you would pay the corresponding. So again, sort of thinking if it's not prepackaged, it's you just dip in and put what you like. That's where the line makes sense. If it's what they call a discrete, discrete means discrete package it's in packages, right? So you can only buy a full box. You can't open it up and say, I only want half the box, so give me just half the box. They're not going to do that. Even if you know the manager, they're probably not going to do that. Okay. So that's the idea. So let's see. Your given table of data, you can only plot those specific values without connecting them, unless the context defines a pattern or rate of change. So whether or not we can connect it really depends on what we're given. But, if they give us a table of values with X and Y, 1, 1, 2, 2, 3, 3, that's really this data here, right? That's all we can do. We can't connect them unless they tell us, this is boxes of cereal. And over here, it's bulk cereal that's in those bins that we could serve up anything we want. Get that right, yeah. Okay. So if they told it was bulk, we could probably connect it with the line and say, yeah, you could buy partial. You don't have to buy a full pound or whatever it is. Okay. So what we have here, take a picture of that. We've got a couple different graphs, and this is just to kind of identify which one goes with which story. Okay. So story A, and again, it is a video example, but I'll walk through it. Andy's selling snow cones for $3 each. This graph shows the revenue earned from selling snow cones. So you sell one snow cone, how much money does he make? $3. He sells two, how much does he make? Six. Sells 3. Can he sell half a snow cone? I guess he's the boss. He could, but probably not. You know, that probably doesn't make sense. So, would it make sense that would be the dotted data? Each time he sells a snow cone, he gets $3. Sells another snow cone, gets another 3. Let's compare that to these other two stories. Andrea is saving money for a trip to Disneyland. Every payday, she sets aside $100 for the trip. She gets paid every 2 weeks. The graph shows the amount of money saved over time. So which one do you think that one's going to apply to?
The last one.
Why?
Because it's every 2 weeks.
So what happens? She gets paid. She saves $100. And what happens for 2 weeks? That $100 sits there. She doesn't put any more money in until she gets 2 weeks. She gets paid. Now she's got $200. That money sits for 2 weeks, and then she gets paid again. Makes another deposit. Now she's got $300 for 2 weeks. It stays at $300. I guess hopefully she's getting some interest, but maybe not. Story doesn't tell us about that. And then she puts in $400, another 100, so she got $400. Good. So that's sort of the step function. We put it in, and then it doesn't change for a while until we get paid again. Good. So this last one, Andrew is walking to school. There are no streets to cross, so he is able to walk at a constant rate. Because if you have to cross a street, you're supposed to do what? Stop, look, listen. Right? You don't have to stop, roll. It's when you're on fire that you roll, right? Drop and roll, that's the other one. We got all these things, right? Grade school, they teach you these things, right? But this one, yeah. Stop, look, listen. What else do you, yeah. Okay, so he's able to walk at constant rate. This graph shows Andrew's distance from home. So does it make sense that as you're covering distance, you're covering an indiscrete amount of distance? You could stop really anywhere. Or keep going. So that's where it makes, yeah. Andrew just kind of keeps on walking. Oops. Yeah. The graph looks better than what I got, so we'll just erase my. You should try this sometime. Try to look up at a screen and draw a straight line. It's just not very easy. Okay. So we'll stick with that one. Okay. So yes, this is the one for C. So the discrete one, again, we're selling a package of thing, a snow cone. It's got a set price, and that's how it goes. Okay. So far, so good. They're just the kind of basics. But these are the types of things you'll actually use really in the real world when you come up with things. There's some times where you can't just, even though there's these dots. In this case, it would not make sense to connect them, like you're selling half of a snow cone, because it's, product is product.
I mean, you could do like a kid size.
Yeah, you could do that. Yeah, maybe different sizes, and then I don't know what, that'd be a mess, but you have dots all over the place. Okay, so. it's kind of, again, some other examples to try. What I want to get us into today is looking at the connection between graphs and equations. Okay, because in this last on test 3 and 4, we were looking at equations, right? At least in unit 3, we were solving equations. What's different about the equations that we have here? Bigger. There we go. There's two variables. Okay, and we're going to more formally talk about it, but there is an x and a y. So that sort of came about in lesson 5 when we were talking about graphs, right? We had ordered pairs. We had an x and a y. And we put them on a graph. But now we want to sort of take a look at this equation. So if I've got this point, -2, -1, what does it mean? What does the first number tell me?
Yes.
It's the value of x. The second number gives me the value of y. So what we want to see is, does this equation satisfy, or sorry, does the point satisfy the equation? How do you know when an equation's satisfied?
When it's equal on both sides.
When it's equal on both sides. I was trying to think of a joke, like when it's had a Snickers or something, you know, but really satisfy. Yes, when they're equal on both sides. So what we're going to do is we're taking the equation we started with, y equals 2x plus 3. We're going to plug the x in for x, so -2 in for x, and -1 in for y. We do the math, and we see if we've got the same number on both sides. So that looks like a -1 goes there. 2 times -2 goes there, plus 3. Now the left-hand side is kind of already done. It's equal to -1. What's 2 times -2? 4 plus 3. So -1 equals -1. Is that true? It's true today, it's true tomorrow, it's true forever. -1 is equal to -1. So this is what we call a point has satisfied an equation. Okay. So what we can say is, for this point, yes, it satisfies this equation. Okay. How about this point? What do we put in for y? 3. What do we put in for x? 0. And again, we just see if it works out. 3, 2 times 0 plus 3. Does it look like it's going to work?
Yes.
2 times 0 is 0. 0 plus 3 is 3. Is 3 equal to 3? Yes, today, tomorrow, forever. So this one's a yes. Hopefully we get one that's a no so we can see what a no looks like, right? Otherwise it just looks like every point's going to work. But, so this one, again, we start off with the same equation. What do we put in for y?
1.
Good. So we were kind of doing this. We called this, what did we call this in the first unit or second unit? When we were given the variables and we plugged them in. Do you remember that? We called it evaluation. They would ask us to evaluate an equation. Sometimes there was 3 things, A, B's, and C's. Do you remember that?
Mm-hmm.
Or have you already forgotten it because it's past? That's okay.
Wait, wouldn't you put 5?
Put
Why is
5
5?
there.
Only if you want to be right. So I like to make mistakes. Because, good, thank you. That's why I got you guys. Keep me on track. So and see, because why did I put the 1 there? Because it comes first and the y comes first. Don't you see how easy it is to mess these up? But you're right, I have to go, oh, the 5 is going to go in for y, and the 1 is going to go in for x. It's because the way they write this, 5 equals 2 times 1 plus 3. So 5 equals 2 times 1 is 2, plus 3 is 5. So 5 equals 5. That also checked. So they gave us some points that all work, that all satisfy this equation. What we're going to see is when we graph them, and this actually takes us the rest of the way through the class, these are the types of equations. We call these linear equations. These equations are actually of a straight line. I'll just let you know that right now. We'll run into some others that aren't straight lines. I'm going to kind of skip over them because they only help you if you're going on into Math 121. For us, everything in this class really is going to be a straight line. Okay, that we're going to test you on. Okay.
So if you look below and it has the graph, why does it matter? Would you transfer that information onto the graph?
Exactly. So then what they did, they gave us all this room. They want us to take those points and put them on the graph. Of course, now we can't see, so y equals 2x plus 3. Let's go ahead and plot these. This is from lesson 5, right? Sort of, this is what we did in lesson 5. So could someone tell me, let's write them down here, what those, -2, -1?
Yeah.
And what was it, 0, 3?
Mm-hmm.
And
1, 5.
1, 5. Okay, so let's plot them. So -2, -1 is down here. Is that right? 0, 3 is here. And 1, 5 is going to be there. So if we plot those, do we get a straight line? Let's see, what color should we use? Green? Okay, so what I'm going to do, go to one of the points, using the straight line tool, go through that. Oops, I'm a little off. Let's see if I can move it back. Nope, I can't move it back. But you saw when I went through it, it looks like a pretty good straight line. If I take this one and I go back to the other one, sort of got too straight. So what we just seen is that these 3 points are on a line. Okay. We're going to study these types of equations where we have y equals, what was it, 2x plus 3. Now this point here, what do we call this kind of point? We had a special name when we were back in lesson 5 looking at graphs. They call this something. What if I write its initials? A vertical intercept. Good. And isn't that, see, now when we think of it in terms of a line, it's where the line intercepts the vertical axis. So yes, this point where x equals 0, this is a vertical intercept. While we didn't identify, what about this point about right here where the line crosses the x-axis? What do we call that? Very good. Or we'll just say it's an HI, Hawaii or hello, or horizontal. Intercept. Okay. How would we find the horizontal intercept? They didn't give it to us as one of the points, right? What do we know about the horizontal intercept?
It's where the two lines meet on a horizontal line.
And what else do we know? There's something that because of its crossing the horizontal axis, there's something we know about one of the values.
Zero.
Something zero. What's zero?
Your
X.
horizontal or vertical.
The,
Y.
the y is zero. The x, as you can see in here, is going to be about negative 1 point something. Okay, so x will be some value, but y will be zero. Vertical intercept, x is 0, y is a value. Okay, so these are two key important concepts. Vertical intercept, x is always 0. If you remember that, and remember it all the way through your math, because it comes up and people in calculus will forget about it. It seems like it's supposed to be an easy question because your teachers are expecting you've been doing this forever, but people forget about that. When you ask for a vertical intercept, they're telling you y equals 0. When they tell you you have a horizontal intercept, what are they telling you about y? It equals 0. Can we say that together like a chorus? When we have a vertical, when we have a horizontal intercept, y is equal 0. When we have a vertical intercept, x is equal to 0. Yeah, so this is, and again, it may seem a little silly, but your mind works in mysterious ways. A lot of your memory is actually in your body, in your muscles, and if you've done any kind of athletics or any type of physical activity, you know this. Sometimes you just know how to do something. Your body responds. And so as you speak, as you write, as you move your body, it comes into the memory. Yeah. It's not all up here, it's throughout your body. Okay. Good. And so and that's basically the thing we're going to keep harping on. Okay. So we're going to deal with things that are lines. So let me ask you something. If I've got this line drawn correctly, which I'm not sure it's absolutely perfect, but does this look like this point is on the line? -3, -3. Yeah. Kind of looks like it, right? So what does that mean? And this is, again, I could be off a little bit, but I think I'm okay. So what does it mean about the point -3, -3?
Satisfies the y equals 2.
It should satisfy this equation. So let's give it a check. I think it'll work. Okay, now I think I did the math in my head. So we put in -3 for y. So this is the y value. So we put -3 in for that. And then 2 times -3, because that's also the x value. So we get -3. What's 2 times -3?
6.
Plus 3. And what's -6 plus 3? Does it work? It does. And what you could do is you could check this one down here. It's, again, my line's not perfect, but I bet you this one goes through. So -4, -5, it will satisfy the equation as well. So what you're seeing is that because this equation, it gives us the whole line. Every point on that line will satisfy the equation. Does that make sense? There's this connection. So the mathematics gives us a visual, a geometric visual, that gives us basically an x and y coordinates, and everywhere on this line are points that will satisfy if we plug them in for x and y. Even these ones that are in the middle, if we could figure out what they are accurately, you know, this one up here, I don't know, They're part way between. If we could get them accurately enough, they would satisfy the equation. There's all kind of points on there. How many points are on the line? Has anyone tried to count them before? Take you a while. Infinite. Even between two little points, there's an infinite number. You'd have to, yeah. So it's an infinite number of points, so don't try to count them. You'll be at it for a long time. Of course, you've got nothing better to do. Can't fall asleep or something. Try to count the number of points on the line. Maybe that'll help you sleep. Get bored real fast. Okay. So far, so good. It's looking like it might be an easy chapter. And I tell you, with this one, as we get into the intercepts, if you remember those two things, vertical intercept has x equals 0, horizontal has y equals 0. I have to kind of do the, it looks like I'm back at Catholic school, you know, crossing myself, but it is, it's up and down. And I did go to Catholic school, first grade. Got in trouble a lot. Got kicked out of class a lot, but hey, that's what a good Catholic does, right? Causes trouble.
Can I ask you a question?
Yes.
Alright, so I'm not understanding why you would go through all that trouble of figuring all those equations out just to put the dots on the line.
How else are you going to get the line?
Why can't you just do those numbers?
Which numbers?
The ones that are in the parentheses and just put them on the line and figure out if it's straight or if it's not.
Sure, you could do that.
But is it to show how the process is done?
Yeah.
Okay.
It's to make that connection, because if we would have put them on there, yeah, I could tell you it and then we do it, but this is to kind of show you. Yes, it's to let you know, because at the beginning, in fact, I haven't really even proved that this gives you a straight line. We would really have to kind of, that's how we would prove it, is we would draw a bunch of line points and do it. But that's why I pulled it up. Once we do have the line, we started pulling points off of the line and it worked. So that's where it does is once we do come to understand and say, we look at that, we accept it and we believe it and we feel it in our gut, it's going to give us a straight line, then it's going to become easier. And in fact, I'm going to show you. We'll start with this because it will say this is the vertical intercept, so we'll put a point at 3. We're going to learn about something called slope, but we don't get there till chapter 9. But this is a slope, and I'll just show it to you. This 2, what would 2 look like as a fraction? 2 over 1, good. Look at this. I go up 2 and I go over 1. I go up 2 and I go over 1. I go up 2 and I go over, and I keep getting back on the line. So the slope will work too. But again, we're going to painfully go through a lot of stuff to try to prove it to you, so you get to experience it, so you can accept it. Some of you will accept it more easily, and then it seems like we're doing a lot of extra work for nothing.
Yeah.
I understand, and that's what school's about. But so it is. But yeah, we could take the short. It's going to work. So yeah, just if you'll all just believe everything I say, we could get done with this class in like 5 minutes. But the problem is then you might not understand it. Okay. But good points. Okay, so we're going to see, yeah, by the time we're done, we'll just look at that. I'll put a point at 3, go up 2 over 1. You got another point, draw a straight line, and we're done. But before that, yeah, we're going to be a little bit painful with it and slow, but we'll try to make it not too painful, not too slow. Good. Okay, I think I already took a picture of this, so we'll just keep going. Okay, and again, notice they keep doing it again and again. Before I cleared that off, let's see if I can get everything back. Let's see if I can get to the right place. There's one more thing I should have shown you, and that's, again, maybe a little bit more than we need, but is this point on the line? No, it's not a quick, yeah. I haven't gone crazy. It's not on the line, but so what's going to happen when we put in 4, -3? to the equation. So y is negative 3. It's not going to be satisfied. It's going to want a refund, right? It's going to send it back. And I want you to, because we haven't looked at a point that doesn't satisfy an equation yet, I wanted you to look at that. 2 times 4 is 8 plus 3. Here's negative 3 equals 11. That's not true, is it? This point doesn't satisfy the equation, and the point's not on the line. Okay. So it also gives us a way, once we do have the line, to quickly identify whether a point's going to work or not, whether it's a solution. Okay. And again, if this graph had some meaning and, you know, maybe it was how many things we sell and how much money we make, we would know whether some sort of, if something is a solution to it or not. Okay, so we can actually use this, and they do this stuff in business. So, you know, where X and Y actually have a particular meaning. Maybe there's this linear relationship. So this is, if we're going to have a solution, it's going to lie along the line. Anything else is not going to be a solution. So business management, these are the ways we can use the mathematics. We use graphing tools, and we see where possible solutions lie and where possible non-solutions are. So, you know, we don't spend a lot of time trying a solution that's not going to work. How many of you have told your boss that's not going to work? Okay, did they listen to you? All the time. Yeah, they don't. But sometimes we just know these things, and we don't have to draw the graph, but sometimes we know because we've done it, we've worked with our hands or whatever, we've done it, and we can tell them that's not going to work. And a lot of time, you know, they're always telling us, do this, do that, it's going to solve the problem. We can sit back and say, we did the graph, it ain't going to work. We know that the point doesn't satisfy the equation, okay? So I want you to see both of those. Not every point will satisfy. In fact, only the points on the line will satisfy that equation. So that's a deep connection. And see, this was not a foregone conclusion. It took people's, you know, they didn't have all this electronic stuff. It took them, some of them, years and years to kind of look at it and prove it. Because they, you know, how do you show that something doesn't exist?
Just make something up.
But no, how do you prove you don't have something? Why do you search me? Well, maybe it's at your home. Maybe it's there. You can prove you have something usually pretty easily. You just show it, right? But proving you don't have something, that something doesn't exist, that's a harder thing to do. Okay. And that's one of the things they did in math. They had to prove what was on the line, but then they also have to prove what's not on the line. And again, to do it really, you have to plug in all those points, and since there's an infinite number of points, that takes a long time. And so all this theory of mathematics we're going is, you know, it took years to build up, but let's see. But we're thankful that somebody else did all the work for us, and we can move forward a lot quicker. Okay. So verify pairs, we're going to go ahead and accept it. Okay. And this, again, they're going to start building this up. I'm going to go through this one a little bit, and yet I'm going to do this a little bit backwards, just because I don't want to bore you too much. We're going to take this idea I said that we could plot the vertical intercept, which is right here. We can use this thing, which I'm going to call the slope, and you will, in a few lessons, you'll start to call it the slope. Right now, they don't let us call it that. But we're going to use it, we're going to graph the line, and then we're going to see if we can pick out these points, and also maybe calculate the points, and hopefully the math and the graph itself should all work together. Okay, so first of all, let's come here. Let me draw an X and Y axis. Let's go ahead and make those in black. Let's see, let's go from here and to there, and let's go from here over to there. Okay, and then I'm going to start with blue point. So can you see here if I put in 0 for x, what's 0 times 1/2? 0. What's 0 minus 2? Still -2. So does it make sense that the vertical intercept x equals 0, y is going to be -2? Okay. And what I could do is I could come here when x is 0, right? Y equals 1/2 times 0 minus 2. Well, that's 0. 0 minus 2 is -2. So I could do one calculation. That gives me an ordered pair, 0, -2. We're all good with that? And we call that the vertical intercept. So what we're going to see is in all our equations we deal with, the vertical intercept is also staring us right in the face. It's the -2. That's the y value of the vertical intercept. I'm going to tell you about the slope, or this number in front of the x. Has anyone heard of something called rise? Overrun. So rise on a graph, which way does the rise go? Up and down. Which coordinate does that work with? The x or the y? Y. So it's affecting the y. So what would happen if I start at this point, because that's the vertical intercept, and we know that that point's on the line or on the graph. If I rise 1, what do I have to do from there? Rising 1, I need to go in the x direction 2, +2. So I rise 1, I run 2. I'm just going to at this point say, I think there might be another point there. If I rise 1, I have to go over 2, and I think there'll be another point there. I rise 1, I go over 2, there should be another point there. I rise 1, I go over 2, there should be another point there. And I could do the other thing. I could, if I drop 1, if I go down 1, what's that like? That's like a -1. So what do I have to do with my run? I have to do a negative run. I have to go back, because a negative over a negative is positive. Good. So we'll see that this will also work. So if I go down 1, I have to go back 2. Doesn't it look like we're getting a nice straight line? Down 1, back 2. That's just for goodness. Let's see. Let's go ahead and make it green. Align. So I'm going to start here. Let's see. Go there. Does that feel okay? Does it feel easy? Does it feel like too easy? Okay. We use a starting point, and from that starting point, we use the number in front of the x, because that's actually, the variable is how things change. We vary the variable, and that's how we change from where we're at. We start at an initial point, and then as x changes, y is going to change. Okay? And it's all due, so notice in this equation, -2 never changes. -2 is always -2. But 1/2 is going to change because it's got an x next to it. As we change the value of x, this term, this component changes, and that's what makes y change. Okay? Because basically every time we calculate something, we subtract 2 from it, and that gives us a new y. So let's see what happens when x is 2. Let's plug one more in here. If I plug in 2 for x, right? So I take my equation, y equals 1/2 times 2 minus 2. What's 1/2 times 2? 1. Or think of it as 2 divided by 2, right? That may be, so that's 1 minus 2. What's 1 minus 2? -1. So this is saying that if I've got the point, if x is 2, y should be -1. Let's see if that's on here. X is 2. Oh my goodness! Look what we got on our line. My goodness, this is cool stuff. okay, maybe that's overacting. I'm trying to get the Oscar, you know, I got to do something. Yeah, Oscar host. Yeah, put in a good word for me. Okay. So we got, what did we do? We put in positive 2, we got negative 1. Do you think that's going to work if we plug in 4? If we plug in 4, 1, 2, 3, 4, do you think we'll get 0?
Yeah.
We better, because we look here and it's on the line. So unless Little Crow has just made all this up, it better work. Okay. And so when we put in 4, we're going to put y equals 1/2 times 4 minus 2. 4 divided by 2 is 2. 2 minus 2, oh shoot, that's 0. Another amazing revelation in the world of mathematics. Isn't that cool? It's like we've got an equation, it matches with the graph, and in this system, we found sort of an easy way to actually draw this graph, but we don't actually have to plot all the points, because that would get tedious, wouldn't it? If we had to plot every single point. We had to plug in a bunch of numbers to an equation every time, calculate it, get all these points, plot them, and then, you know, isn't it nice that we can just plot one point, and then from the slope, we can get as many as we want. And then if we got a straight edge, we just draw it, and we're good to go. But what I want you to do is I want you to do it once or twice, but I want you to do it mindfully and deeply. You know, pay attention to what you're doing. As you're doing it, get as excited as I am, you know. I know your family's going to think you've gone off the deep end. Why are you so excited? Oh, I'm doing my math homework. It's just such exciting stuff, right? I know they're going to think you're crazy, but we all know we're not. Or at least, if we are, we're all crazy together, right? So that's okay. But do this, you know, this is a good activity to go through. And you'll see once you start doing it, you know, this number here, that's our vertical intercept, plotted. And then this number in front is our slope. It's a rise over run. And you're right, we're going to painfully go through a lot of these things, and you're just going to say, I already understand this. And that's my goal, is I've told you the secrets to the universe, like 3 units ahead of schedule. And so now you're going to be able to go through it quicker, and you're going to be able to scoff on them a little bit and keep moving forward. But what you do is you know the big story now. So you're not going to be so surprised when you find out that Darth Vader is actually Luke Skywalker's father, isn't he?
Yeah.
I didn't know that. Oops, oh, sorry, I didn't blow up for anyone. But yeah, when it first came out, we didn't know that stuff. But now that we know, you can watch the movie and enjoy it. Yeah, see the twists and plots. You know the story. Okay. Times. Okay, we're doing good. Take the picture. Okay, but isn't this feeling better so far than what we were doing before? Because we have a visual connection to it. So this is what's really nice about this is if you are a visual learner, you've got something to connect to. If you're not, you've got the abstract learners, you've got your abstract equation you can deal with. And you've got concrete points that kind of connect the two together. So there's a little bit of something for everybody here, but there's a way to get a handle on things, but you do need to go through, practice, and do a few of these. Okay? And again, if you at least give this one a try, I'm giving you a preview of how we're going to be graphing these, but you'll see soon enough. Okay. Example 2. I suggest skip it. Why do I say skip it? Because of this pesky thing here. Does anyone know what an x squared looks like? And I'll say, what does an x squared look like? Well, if you square a number, what do you always get? What kind of number do you get when you square something? What's that?
Equal?
What do you mean by that?
Well, it's the number of times itself.
Good. So if I take 1 squared, 1 times 1 is 1. That's not, then I add pi to it. But if I square, say, a negative 5, what do I get?
Negative 20. Or are you multiplying?
25.
What?
25.
Positive
Oh,
25.
25.
Because it's negative 5 times negative 5 gives us
Okay, so
positive.
that's
So the trick is that when x is negative, actually it becomes, when I square a number, I always get positive. So I won't, basically to throw it at you, you get a graph that looks something, you get a U-shaped thing, okay,
with those.
with those. This is something you're going to deal with if you go into Math 121. If you go into Math 141, you won't see this. So I say, why even spend any time on it? These ones, and these are not straight lines, so this takes a lot of time. You actually have to plot all the points. It's a lot of work for what? It's not going to be on the test. It's not what we're wanting to focus on. It's okay about function stuff, but I'll tell you what, if you have to do 121, wait till then, you'll have the tools to deal with it. That's what I say. So when you see x squareds in this class, skip them. Just a lot of extra. It'll take you twice as long to do it, and you won't ever use it again. And then you'll get angry with me for giving you that kind of homework. And I'll say, don't get angry with me. I was the one that told you to skip it, right? So, yeah, ignore them. Again, when you get to 121, there's plenty of time to take a look at these. I want to focus real deeply on straight lines. That's all I want to talk about, because that's all you're going to need for the test. That's all. If I can get you to understand straight lines, because actually straight lines are one of the hardest things to understand in mathematics. But once you do understand them, everything else is much easier to deal with. And one of the problems we have is we start putting in too many tangents when we teach you math. It's not like it wasn't enough to do, right? So, we okay? We'll just skip these guys in the future. Don't even pay attention to them. They're just not even worth the mental energy they take up. But, you know, they have their place. I don't know. I didn't want to hurt anybody's feelings, but because they actually are, like if you throw up something, throw a baseball up. I don't want to throw up. There's enough of that last week, right? If you throw something up in the air, it will actually follow this is called a parabola. So this is all important stuff. But again, there's a whole class that will deal with it. They just sprinkle a few of these in here to take a lot of time and not really give us much of anything. Okay, so where are we? Let's clear this out. And then I think the one after this. So what do you think about this one?
Well, it's the same if you talk about square.
But it's not squared because it's got the exponent up. This is called an exponential. And again, if you take 121, you'll study it deeply. But we're not at 121. And again, they just throw it at us, and it's, for those who are worried about it, it's a graph that sort of looks like this. Okay, so it's but it's not a straight line, and I want more time to work with straight lines. Because if I can get you masters of straight lines, your mathematics will just rocket out of here. It'll do it, the exponentials. And those of you who need to do exponentials, there's plenty of time in the other class to deal with them. They shouldn't even be in here. If I could erase them, I would, but I'm not the one who makes these books. So I'm just the one that tells you when you see an exponent, any kind of exponent. So yeah, there's kind of like x squared or 2 to the x. For us, let's just skip it. It is not worth the time. They're not worth the paper they're written on. Let's put it that way.
Those won't be on the test.
They won't be on the test. If they happen to sneak on the test, I'll delete them off of there too. No, they're not going to be on the test. They're not on the test. I want to spend more time with straight line functions, with linears. Okay? So I want you to pass these up. And what do you think we're going to do with this one?
Go down.
Absolute value.
It's absolute value. They don't even cover these in 121. Maybe 150. So why should we talk about them now when it's going to be 2 semesters before you might even do it, or you might, if you go to 141, you'll never see it. Okay. So, but again, just to get you, it's called an absolute value. So absolute value makes things positive. So just like the last one, you get graphs that sort of, but it gets a sharp point, so you get V-shaped graphs. Okay. So instead of being a straight line, it causes the part that would have gone into the negative would have fallen to bounce up. Okay. Again, plenty of time in the future to deal with these. And as far as the curriculum, it happens in Math 150. For those of you who are going to take 150, that's 2 classes down. You'll take 121 and then 150. When you get to it, perfect time to talk about it. For right now, it's a waste of time. So I want more time on straight lines, so that once you understand straight lines, you can take the time to reflect on them and understand them deeply. And then all of this stuff fits in. If you start diversity, looking at all this other stuff, you'll just get confused, at least if you're like me. And then you'll have to spend years in therapy to recover from what your math teacher did to you. So I don't want to do that to any of you, so we'll skip it. Okay. So again, that's nice. It's a quick way to get through a lesson. Just skip it all. So now we're to the stuff I want to talk about. Intercepts. Okay. This is what we came for. And we'll spend about 15 or 20 minutes and we're going to get down because this part is so cool. What do you need to remember about this one part on intercepts, if you remember? There's just 2 things, actually, 2 rules you need to remember about intercepts. Oops. What's the important number when we're talking about intercepts? 0. And there's 2 kinds of intercepts. A vertical intercept. The vertical intercept always has what?
0 for the x.
0 for the x. They call it the input too. So x will always be 0. This is a mate. Once you understand this, this is all there is to a vertical intercept. It's got x equals 0. And what I'm going to do, I'm going to put this as an ordered pair, 0, comma y. Okay. Every single frickin' vertical intercept you see in the world has x equals 0. Y can be anything because it's going to be along that vertical, but x will always be 0. If x weren't 0, where would we be? We would be off the vertical. We'd be over here, right? If x was 1, we're not on the vertical intercept anymore. If x was -3, we're over here, right? The only way we can be on this vertical intercept, this vertical thing, is for x to be 0. Okay. Does that make sense? Make deep sense? You gonna remember it? Promise? Get it tattooed to the back of your hand? Good. The coordinates of the vertical intercept will be, so actually I jumped ahead of myself, but I like to be redundant, 0, comma y. Determine the vertical intercept. Set x equal to 0. X is 0, x is 0, x is 0. Just say it 100 times and you got it. Or maybe 99, whatever you like. Say it a lot though. X equals 0, that's our vertical intercept. If I tell you I got a vertical intercept, what else am I telling you? Whether I tell you or not, I'm telling you x is
0, 0.
perfect. That's all I got to tell you. Now, the other part of the story, the other half, and this is all there is to this, what's a horizontal intercept? Well, go ahead.
0.
0 where?
Y.
But
For the y, for the output value. Simple. A lot of times when you start looking at math, there's this, if you know one side, the other is just the reflection, just the opposite. Okay? Just like life. So the horizontal intercept always has what we said, y is 0. Okay? So I'm going to do it both this way. x is some value, but y is 0. The coordinates of the horizontal line intercept will be x comma 0. So I double dip there. And to determine the horizontal intercept, how can I find a horizontal intercept? I set y equals 0. Plug that in and figure out what x is. That's how I get it. So this is all there is to it. It's so simple, but at the same time so hard to actually apply. But it really is. It's because we think it's got to be more difficult or something. I don't know what it is. I had difficulties with this. I don't even know why anymore, because it just seems so simple. X is 0 for vertical intercepts, y is 0 for horizontal. I don't remember, it's hard because the two words, horizontal and vertical, right? Anyone else have problems keeping those two straight? That's why I do this for horizontal, because it reminds me, and I have to do this for vertical. So, you know, do what
Or
you
if
need
you're
to do.
laying down your horizontal, and if you're standing up, you're vertical.
There you go. Whatever it takes to remember it. But it's, you know, there's always a few things in there that makes it difficult, but we can always find ways around the difficulties. So let's go ahead and we're going to take a look at a few examples. But remember this, you know, the first time we went through this new material, I gave a test and I put a lot of things on intercepts because I just assumed it would be easy. But maybe I didn't stress it as much as I'm stressing it now. And the reason I stress it so much is I thought, man, everyone's just going to ace this test on intercepts. But only a few did. And I don't know why. I think because I didn't emphasize it enough. Okay, so we're back to this one. And the thing is if we have vertical intercept and a horizontal intercept, if they're different, how many points do we end up getting? 2. If we have 2 points, what can we do as far as a line? You can draw the line. And because if you have 2 points, there's only one line that will go through those 2 points. That's one straight line. And when we're talking math lines, they're all straight. Okay. So one method, again, we've actually already seen we could use slope and intercept. So we would go to -2 and then rise 3, run 1. We saw that that would work. But the other way to do it is to use intercepts. So a lot of times we'll find the vertical intercept first. So we put in 0 for x and then find y. So let's do that. Y equals 3 times 0 minus 2. What's 3 times 0? 0 minus 2. It just kind of 0 just disappears out of it. It's going to give us 0, -2. So after a while, you just say, well, when x is 0, the only thing that's left is the -2. And we call that what? What kind of intercept is this one? Vertical. Good. And we graph it there, so now we've got verification. How do we find the horizontal intercept? See, I already forgot. Y is 0. Okay, so we come over here, we're going to put 0 in for y. So that gives us 0 equals 3x minus 2. This is a little bit harder because now we need to use our skills that we picked up previously in lesson 3. We have to solve for x. Notice when we have it set up over here, 3 times 0 is 0, and then it just happens. And you'll see with linear equations, the vertical intercept is going to be very easy to find. It's this one that's a little harder. So what do we have to do first? Add 2 to the other side. Okay, so we're going to add 2. And then -2 and 2, those cancel out, becoming 0. What's next? Divide both sides by 3, so x is by itself. So x equals 2/3. And so we come here, we know that y was 0, and x is 2/3. how do we plot 2/3? 0, there's 1/3, there's 2/3. It's kind of an estimation job, right? We get the point right there. Let's see if that worked out pretty good, because let's do our old system. -2, there's the vertical intercept. If we rise 3, 1, 2, 3, and run 1, we should have a point. Is that correct? So then if we come up here to our line drawing tool, we should be able to go through this point. Yeah, looks like it lines up pretty good. And again, this was an estimate, but there, all the points are on the line. So I might go with this one coming down. That's about right, something like that. I messed it up at the end. But we draw a straight line. So as long as we have 2 points, we can draw a line. So there's some activities in here that you go through. You find horizontal intercepts and vertical intercepts, and that's why. Because if they're 2 separate ones, we can draw a line. We can get 2 points and draw the line and be done. Is there a possibility that we only get 1 point when we find the vertical and horizontal intercept? Is there a possibility that the horizontal and vertical intercept could be the same? 0 what? 0, 0. It needs to be double because it needs the x and y. So it is possible, and so that's any line that goes through 0, 0. The vertical and the horizontal are the same point. So if you get that to happen, you need to find another point, right? But that's a special case. Good. So it could happen. But other than that, most lines, if you have the vertical intercept and the horizontal intercept, you can draw, they're 2 separate points, you can draw the line. So there's a whole mathematics, they have you do those problems again and again. Again, I just want you to focus on learning this stuff. So I find if you do a few problems deeply is better than doing twice as many problems without thinking about it too much, because you'll remember it better. So don't work a lot, work deeply.
When you did the 2 up, 3 over, did you start from 0?
Always start from the point. No, I did not start from 0, 0. So
Okay.
I don't know what that green point is. What happened there? Well, because I was talking about it later. And that's good, because I'll see students that will do that. They start from 0, 0, they'll go up 3 and over 1, and they'll put that point. But we always have to start from a point that's already on the line. So that's why we start with the vertical intercept, because we know that is on the line. Yeah, you can't just start someplace out here and say, okay, go up 3 over 1 and you get another point. You have to start on the line, and then the slope gets you back to the line. Okay. And again, if I draw it accurately enough, we could find, I think maybe this might be here, up 3, yeah, over 1. So it should actually be going through this point here too. But again, sometimes if you get a bit of slant on your line, you can be off real quick. How are we doing so far? Is it making sense? Okay, so when I got a vertical intercept, what is 0?
Y. X.
X. When I have a horizontal intercept, what is 0? Y. When I have a vertical intercept, what is 0? I have a horizontal intercept, y is 0. Okay. And again, it sounds a little corny, but that if you get those 2 things down, and again, I work with students in the tutor center taking calculus or Calc 3, and they'll have problems. I'm not like this math genius guy, but I'll point out the simple things that they forget. They forget this stuff. Yeah, they're very smart in a lot of other things. They forget the simple things. So that's why, if you can remember the simple things, you'll go far. That's why I want to narrow it down. I only want to teach you the important things. I don't want you wasting your time on those x squareds, those exponentials, even those absolute values, because they're not on the test, they're not in this competencies for this class. They, part of what they're trying to do is prepare you for that next one, but not all of you are going to take 121 anyway. A lot of you will go to 141. In fact, most of you will probably go that route. So when you get to 121, there's plenty of time to deal with them then. Let's not worry about them now. Okay. I think I took a picture. Starting to lose my voice. Gave everything I had for you guys. And you all appreciate it, don't you? And then horizontal and vertical lines. What I want to do is I want to step back from this, because if we cover it today, you'll really get confused, because it's another simple concept, but I want you to focus on what? Intercepts. Horizontal intercepts have y equals 0. Vertical intercepts have x equals 0. Just kind of remember, it's sort of backwards of what you think. The y-axis, x is 0. The x-axis, y is 0. And along those axes, along those intercepts, along the horizontal intercepts, x can be anything it wants, but y has to be 0. Vertical intercepts, y can be any number, but x has to be 0. It's like those singers, when they don't have to say the last word, they just put the mic out and you all sing the last words because you know it so well, right? That's what I want. I want you to know vertical intercept. You already forgot. Vertical intercept.
X is 0.
Awesome. Horizontal intercept.
Y is 0.
That was my last voice. Awesome. That's it. You'll remember it for the rest of your lives now. Good. So that's really all we want to look at today. Monday we'll come and we'll look at horizontal lines. This is all going to be easy stuff for us. Then we'll start to look a little bit at 7 and start getting ready for spring break. Okay. Thanks for those who attended via live stream. We're going to sign off now. Work on your homework. Remember,
Oh, this is gonna be okay.